Starting with exercise 10.1, the first question is, draw a quadrilateral in the Cartesian plane whose vertices are -4, 5, 0, 7, 5, -5 and -4, -2. These are the points, 4 points given for the quadrilateral. You have to draw it on the graph and you have to find out its area also, that is area of the required quadrilateral. Okay, so first we are drawing, we have just taken the plane or the graph paper and plotted the points -4, 5, 0, 7, -4, -2 and 5, -5 and joined all the points so that we got the quadrilateral. Now the question is, you have to find out the area also. Now to find out the area of the quadrilateral, that is area of quadrilateral ABCD. I have given the names ABCD, and this touching point on the axis I have taken it as E. Okay, why? Because I am just breaking this quadrilateral into two parts. One, you can see a trapezium and the other one a triangle. Along this axis you can see this is a trapezium and this is a triangle. So I am just taking the area of both and then adding them in order to get the area of the quadrilateral. Okay, so area of quadrilateral will give you area of triangle BCE plus area of trapezium ABED. Okay, so these are the two things, and the addition of these two will give you the area of the quadrilateral. Now how to find out the area of the triangle from the figure or from the graph? From the graph it will be easy for you to find out, because this length we can find, this length, every length we will get from the graph itself. Okay, so you can use your half BH concept. So half BH plus, here you know, half into A plus B into H is the formula. There, these are these two sides, and H is the distance between the two sides, and BH in this area of triangle you have half into base into altitude. Now for the triangle we'll move. So here you can see this is acting as the base, that is BE is base, and here you have to take a perpendicular so that you will get H. Because it is an obtuse angle forming, you will have here the height, and this is again 5 in length. Okay, so what you can have, half into base. Now for base it is 7 here. Here it will touch the axis at, you can just see in the graph, it will be somewhat 3.4. So it is coordinate is 0, -3.4. So this distance is 3.4, this distance is 7. 7 plus 3.4 will give you 10.4. So B is 10.4 into H is this length, so that is your 5, plus half into A. Here for this trapezium, if this is acting as A, this will be B. This length already you have found out, it is 10.4, plus what is this length? See, it is a line here, -4, -4, and this is 5, 2. That means you'll get y2 minus y1 as the distance. So you'll get 5 minus of -2, which is 5 plus 2, 7. Okay, so that is your B. And H, what is the height? This is H. This H is 4 till 4, so it is 4. Okay, into 4. So calculating this will give you your area of the quadrilateral. So it is 5.2 into 5 plus 2 into 17.4. Now what is that? So this will give you 26 plus this will give you 34.8, so that you will get 60.8 centimeter square or square centimeters. Since you have taken in the graph, each one is centimeters. Okay, so this is the area of the quadrilateral ABCD. You can just make it a square units, because centimeter is not given. You can just take square units. Any unit which is given will give you your square of that. Okay. Question number 2 is, the base of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is at the origin. Find the vertices of the triangle. So the condition which they have given us, the base of the equilateral line. So you have to consider the equilateral triangle, that is all the three sides are equal. And if they are saying with side 2A, that means each of the sides of the equilateral triangle which you are taking will be 2a. Okay, but the base should lie on the y-axis, along the y-axis, and the midpoint of the base, that means if I am taking this is the base along the y-axis, midpoint of the base should lie on the at the origin. So this is 0, 0 origin. Here will be the midpoint, means this distance and this distance for the equilateral triangle. In total it has 2a, means here also a, here a. Okay, so suppose this is the equal parts divided in the upper part and lower part of the x-axis. So here you can say this point will be 0 comma a, and then this part will be 0 comma minus a, because the total should give you 2a. So a minus of minus a will give you 2a. So this is the base, acting as the base. Now they are saying that you have to find out the vertices, means already we got these two vertices. That means the third vertex is the main thing which we need to find out. And again it will lie on the, since this is the midpoint equilateral triangle, its third side will be passing through this. That means the third point will be lying on the x-axis. It can be either in this form or in this form, right? Or in this form. So we will consider the third vertex. The third vertex of the triangle B, since the coordinate it is lying on the x-axis, means the second coordinate will be 0. So if I am taking this part, it will be positive. If I am taking this part, it will be negative of the same value. So either it can be plus x comma 0 or it can be minus x comma 0. So the third vertex in general I am taking plus or minus of x comma 0. Plus or minus x comma 0. So my purpose is to find out what is the value of this x. Okay. So the two other vertices are 0a and 0 minus a. Now the concept which we are using is area of the triangle. So you need not consider both the things simultaneously, okay, either of them, and while substituting for the vertex you will get both the conditions together. It can be either here or there. That's why we are taking plus or minus. Now suppose consider this. So you can say that this length is 2a, again this will be 2a and this will be also 2a. And this length will be x, right? Since this is 0, 0 and this is x0, this length is x, okay? So you can use your two concept, which is area of any triangle is half BH, like that, okay? So you can just consider half BH concept, as well as you can consider the area of an equilateral triangle, and both should be same. So we are just considering area of triangle will be, of a triangle will be half BH, and it will be same as, since it is equilateral triangle, you have root 3 a square, that is side square, by 4. Okay, now we are just replacing half into what will be the base of the triangle. This is half b. Okay, so here you will get 2a into what is acting as height, x, is equal to, we are not substituting plus or minus here, for the vertex we will substitute. Okay, root 3 by 4 into, again what is the side, 3 sides are equal and the side's length is given to be 2a, so it is 2a square. Okay, so this get cancelled, you are getting x into a is equal to root 3 by 4 into 4a square, so that it is root 3a square. X into a is root 3a square, a get cancelled, a cannot be 0 because it is having certain length, right? That's why we are cancelling. So you are getting x is equal to root 3a. So when x is root 3a, the third vertex will be, plus or minus root 3a comma 0. Okay, and the question is find all the vertices of the triangle. Therefore, the vertices of the triangle can be, of the equilateral triangle will be, either you will have this, this and this. That means it will be either 0 comma a, 0 comma minus a and root 3 comma 0, or you can have 0 comma a, 0 minus a and minus root 3 0. Okay, if it is in this part it will be minus root 3 comma 0. Question number 3 is find the distance between P of x1 y1 and Q of x2 y2 when first part is given as PQ is parallel to y-axis and second one is PQ is parallel to x-axis. So here if I consider P and Q to be points, then what will be the distance between the points P and Q? Distance between P x1 y1 and Q x2 y2 is generally given by the formula PQ is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now in the first subdivision, they're asking us to find out when PQ is parallel to y-axis. That means if PQ is parallel to y-axis means in this form, suppose this is your PQ, the coordinate is x2, y2 here and this is x1, y1 here. Now you can see that since it is parallel to y-axis, this coordinate will be same. If it is x1, this should also be equal to x1. That means the x coordinate will be same for both P and Q. Or you can say since PQ is taken as parallel to y-axis, this implies that x2 is equal to x1, right? x2 equal to x1 will give you x2 minus x1 is equal to 0. Now you go for the formula, therefore PQ will be root of x2 minus x1 will be 0 square plus y2 minus y1 the whole square, which will give you root of y2 minus y1 the whole square or y2 minus y1. Root and square will go. And since it is distance, you are just showing that it is only taken as positive, so that you are just representing it as modulus. Okay, mod of y2 minus y1 will be PQ when PQ is parallel to y-axis. Now for the second part, if you are taking PQ to be parallel to x-axis, you will draw it like this. It is parallel to, it can be anywhere, okay, parallel here or here. But the thing is, if this is P and this is Q, the y coordinate will be same. So if you have P as x1 y1 and Q as x2 y2, y1 should be equal to y2, right? So this implies, since it is parallel to x-axis, y1 or y2 is equal to y1, or this will give you y2 minus y1 is equal to 0. Therefore, the distance PQ will be root of x2 minus x1 the whole square plus you're substituting 0 square. So that it will become root of x2 minus x1 the whole square or x2 minus x1 with the modulus in order to give it as a positive value. Okay. So parallel to y-axis will give you mod of y2 minus y1 as the distance PQ, and parallel to x-axis will give you PQ as mod of x2 minus x1. Fourth question is, find a point on the x-axis which is equidistant from the 2 points given, that is 7, 6 and 3, 4. So since the point which you have to find out is on the x-axis, the form of the point will be x, 0. So let P of x, 0 be the point on the x-axis, okay, and let the other points be Q and R be the other points. Okay, now what is given? This point is equidistant from these 2 points. Suppose this is P, this is Q, this is R. This is only supposition. This is x, 0. Here it is 7, 6 and this is 3, 4. They are saying that they are equidistant. Equidistant means PQ is equal to PR. So that concept we are using here in order to get the value of x. Okay. So first, what is PQ? PQ will be, again, distance formula you can use, root of x2 minus x1 the whole square. So you will get either 7 minus x or x minus 7. You can do in any of the manner. So x minus 7 the whole square plus 0 minus 6 the whole square is your PQ, which is root of, here you will get x square minus 14x plus 49. This will give you plus 36. Or this is root of x square minus 14x plus 85. Now what is PR? These two are equal, no? So we are finding out these two values. Okay, PR is root of, again you can use the same, x2 minus x1 the whole square will give you x minus 3 the whole square plus 0 minus 4 the whole square. Don't confuse, you can just write as 3 minus x the whole square plus 4 minus 0 the whole square also will give you the same answer. Okay, so here you are having x square minus 6x plus 9 plus 16, which is giving you root of x square minus 6x plus 25. Now the concept which we know is, or it is given in the question, that they are equidistant. So that since PQ is equal to PR, you are just replacing the value of PQ, which is root of x square minus 14x plus 85 is equal to root of x square minus 6x plus 25. Now both are having root and we have to solve, means we can just square and remove that root. Okay, squaring both sides, we will get x square minus 14x plus 85 is equal to x square minus 6x plus 25. X square get cancelled. Here you have minus 14x. This will come here as plus 6x is equal to, here you have 25 minus 85. This is giving you minus 8x. Here you will have minus 60. Okay, so that you are getting your x to be minus 60 by minus 8 or 15 by 2. Therefore, the point on the x-axis, which is equidistant from both P, Q and R, is 15 by 2, 0. Okay, unless and until you write this as a point form, you will lose marks. So you have to write this point form also, that is 15 by 2, 0 also.